Last class, I discussed about the phasor diagram of transformer at lagging load and leading load condition. Today, I discuss about the transformer equivalent circuit. How uh, you will draw, how to draw transformer equivalent circuit. First of all, I draw a simple transformer. Here in secondary side, uh, a impedance Z2 is connected. Okay. Now the secondary current, that is I2, flow in this direction. So secondary impedance Z2 can be written as V2 by I2. That is the load impedance here. Now from the transformer equation, we know that V1 by V2 equal to N1 by N2. So V1 by N1 equal to V2 by N2. Again, we know that the primary MMF is equal to the secondary MMF, that is I1 N1 equal to I2 N2. So from this equation, the value of I1 is nothing but I1 I2 N2 by N1. Now V1 is V2 by N2 into N1. So V1 by I1 is V2 by N2 into N1, and the value of I1, this one, is N1 into I2. So V2 by I2 into N1 by N2 whole square. So V2 by I2 already known, that is Z2, that is Z2 into N1 by N2 square. From this equation, the effect of Z2, on the primary side is nothing but Z2 into N1 by N2 whole square. Look at the second picture, that is this one. Okay, so as far as effect of Z2 on primary side concerned, impedance Z2 in the secondary side can be replaced by the equivalent impedance, that is Z2 dash equal to Z2 into N1 by N2 whole square. Similarly, if we take the impedance in primary side, suppose Z1, okay, then it can be referred to the secondary. That time Z1 dash equals to Z1 into N2 by N1 whole square. Remember that if we take a impedance in primary side, if it is transferred to the secondary, that time we written as Z1 into N2 by N1 whole square. Similarly, we can transfer the voltage as well as the current referred to the primary or referred to the secondary. Now from the last class, from the phasor diagram, from the phasor sum, that is value of V1 and value of E2 is nothing but V1 equal to V1 dash I1 R1 plus JX1 and E2 equal to V2 plus I2 R2 plus JX2. Now from these two equation helps to build up the phasor diagram. Here exciting current is neglected. Here exciting current is neglected. That is R1 plus JX1 we are drawing here in primary side resistance, primary side reactance. I1 current flow through the primary path. Similarly, taking R2 is the secondary resistance, JX2 is the secondary reactance. I2 current flow through the secondary part. V1 prime voltage, this one in the primary, E2 is the secondary induced voltage and V2 is the load side voltage. So from this two equation we simply draw the equivalent circuit where the exciting current is neglected. What is equivalent circuit? The equivalent circuit in electromagnetic device consists combination of resistance, inductance, capacitance, voltage, current, etc. So equivalent circuit actually consists of the resistance, inductance, capacitance, voltage, current, etc. Here the V1 dash, that the voltage drop in the direction of I1. V1 dash actually does not depend upon the changes of load, that is no load to full load. The actually V1 dash magnitude depends upon the frequency, phi max and number of turn, so that we can read the V1 dash equals to E1. The magnitude of V1 dash equals to E1. It is depends upon only the frequency, phi max and N1. From the phasor diagram, the primary current I1 has two component, a compensating component I1 dash, that is diametrically opposite to the secondary winding current I2, and a exciting component current IE. Again, the exciting component current has two component. One is the magnetizing component and another is the core component current. We know that the core component current in phase with V1 dash and product of V1 dash into IC gives the core loss. Okay. If the core have resistance RC, the RC is in parallel with the V1 dash. So simply PC, that is core loss, is V1 dash into IC, and that can be written as IC square into RC, and RC here V1 dash divided by IC. Again, exciting current have another component, that is IA, magnetizing component current. It is lags the V1 dash voltage by 90 degree. Okay, therefore it is in imaginary axis. So we know in imaginary axis reactance is placed. So from this concept we can write the core reactance Xm is nothing but V1 dash divided by Im. Again I say the effect of higher order harmonics cannot be represented in the equivalence circuit as well as in the phasor diagram. Actually, we consider the magnetizing curve is linear. This is the exact equivalence circuit, that is the we are taking ideal transformer. This is the primary resistance, primary reactance, core component resistance, core reactance, IE current flow, here IC current flow, here IM current flow. This is the supply voltage V1. Okay, total primary current I1. I1 has two components, IE and I1 dash. Okay, similarly this is secondary induced EMF. This is JX2, this is R2, and secondary side voltage V2. Okay, and here this is the V1 dash prime. Okay. So this is the representative of ideal transformer exact equivalent circuit. Student, if you have any problem, please contact me.